0.4 is called roots. Example 1 wants us to evaluate the following. So I have negative and then root 49. So the square root of 49 is 7, we should know that, and there's a negative sign, so it's just negative 7. Now I don't need to worry about a plus or minus unless I am solving for a variable. So no plus or minus here, just negative 7. My next problem, I have a rule with square roots that when I have multiplication or division, I can split it into separate parts and just do them separately. It also works for cube roots. So I can do the cube root of 64 over the cube root of 27. And I know that 4 times 4 is 8. Sorry, 4 times 4 is not 8. 4 times 4 is 16. Times 4 is 64. So 4 to the third is 64. So the third root of 64 is 4. I'm going to show another way to see that. The third root of 4 to the third is what this top part's equivalent to. On bottom, the third root of 3 to the third is what 27 is equivalent to, because 3 times 3 is 9, times 3 is 27. And then the third roots can cancel on top and bottom. The third root with a third exponent cancels, giving me a 4 over 3. And that is my answer for that problem. Then for the last one here, there are, if I look at this, I would need things that multiply to give me negative 121. Now, I'm going to rewrite this for a second. Some of you might be thinking, okay, I'm going to try to do this. You could separate it to a negative 1 and a 121 fourth root, but that by itself, we don't have an answer for that. Like, we can't do it. There's no separate letter. Like, the square root of negative 1 is I, and you can kind of finagle things to work here. Like, technically I could get an answer, it's going to be imaginary and it's going to look real weird. But for now, we're just going to say no real roots. So if there's imaginary stuff, you can say no real roots in this section.